This question 3, it's all about functions. In the description box, I'm going to leave links for other questions that I've discussed or recorded for this question paper. Now, question 3, it's all about functions. Check. This is a long question. It's a long question and it covers all the functions discussed that were discussed in class. So in 3.1, I have a exponential and a straight line. The first two functions, there's 4 in total. Let's hide this. Then there's 3.2 where we're going to do a sketch for a hyperbolic function. This is a hyperbola. And for the last question, 3.3, it's a parabola and a hyperbola. Okay, a hyperbola. So all of the functions were covered. Now, going back to the first equation, we're going to start here. Now, what are we given for 3.1? So we have the graphs of f, which is the exponential, and the graph of g, which is the straight line, are sketched below. We have point A. This is point A, which is the point of intersection as well. Point of intersection. The point A, it's the point of intersection between the straight line and the exponential. Then we have B, which is the y-intercept for the straight line. And then we have point C, which is just a random point on the straight line. Well, it's a useful point, but it might be a useful point, and it has no significance. Are the points of F and G. So all of these points are the points lying on F and G. Now, for the exponential graph, we only have one point that lies on this graph. It's point what? Point A. Now, we are done interpreting here. We are done reading through the question and just understanding the sketch in general. Now, for the first question, we are asked to determine the values of a and q of the function f. Let's take the function f and write it on the side. This is a multiplied by 2 raised to exponent x plus q. So they want us to calculate what? A and q. So when it comes to questions such as these, where you have to find an unknown value or an unknown variable, right? The value for a variable, you need to use a point that lies on that equation, that lies on that function. So since f of x, it's the exponential function, so we're gonna use the point A to work out the values for A and Q. But if you take a look at the function very closely, very closely, the Q, it's known to be the asymptote. So looking at your function, you can see that your asymptote is actually y equal to minus 1. So the minus 1, it's actually equivalent to q. So we have the first value for q, which is minus 1. So our next task would be to calculate the value for a. All right, so I'm going to use the point A to work out the value for a, the small letter a, right? So I'm using the coordinates for a to work out what the a value is. So where there's y, I'm going to substitute 1. Where there's x, I'm going to substitute 2. So let's go ahead and substitute into this equation. So y, it's 1 equal to a, we don't know, that's what we are looking for. Then x is going to be 2, then minus 1 on this side. So we have 1, transpose the 1 to the other side, it's a plus 1 equal to a multiplied by 4. Then a 1 and a 1 gives us a 2, and then we have a 4a this side. We divide by 4, cancel, a is equal to a half. This is our answer. A equal to a half, and then q is equal to a minus 1. So these are the values that we were looking for. All right, now looking at the next question, you can see that if f of x is equal to, surprise surprise, a it's a half, q it's a negative 1. So just by sanyana nje. Yeah, or let me just say they're giving you the answer on the next question, right? So we have 3.1.2. They want us to give the range of the function of f of x plus 3. The plus 3 added to the f of x function. This simply means that the function has been moved upwards by how many units? 3 units. It also means that the domain, the range has also shifted up by 3 units. Okay. This is the original function. I'm highlighting it in blue. This is the original function, which is y, well, let me just use the same notation. F of x is equal to a half times 2 raised to exponent x minus 1. So this is f of x. The blue stuff you see, it's f of x, right? Now, question. What is the range of the blue function? Let's write it down. The range is all the set of y values. So y is element of, we exclude the minus 1, which is the asymptote going all the way up to positive infinity. Or you can quote it like this. Just say y is greater than minus 1. Now here's the catch. This is not the domain. This is not the range that we are looking for. We are looking for the range of the graph f of x plus 3. So what actually happened is they took the f of x and added 3. This means that the graph is shifted upward by how many units? 3 units. So from here to here to here to here. 1, 2, 3. So the new function is going to look somewhat like this. So this means that the function has been shifted upward by how many units? 3 units. Now, they want us to give the domain for the new function, the green function. So the answer for this question is going to be y element of negative 1 plus 3. Y element of, this is the final answer, a plus 2. This is the new range. So the added 3 to the function, we also added to the range to get the new range. Okay. Next question, 3.3. They want us to give the domain of the graph of G. Who's G? Yeah, okay, G is the straight line. Yes. All right. That's an easy one. So let's give them the domain. Okay. Now let's proceed with caution. Okay. Wow. Okay. That's an interesting question. Now just pay attention to the straight line. Let me use this one, this color. The purple function, this one, it's the straight line. That's g of x. This is g of x. But now, look at the ends of the line. The end points of the line. The arrow simply means that the function continues to infinity. But at point C, it's where the graph stops. Right? Maybe this could be the starting point, and then it falls like this all the way up to infinity. So the domain, okay, The domain for a straight line, it's normally x element of real numbers. But in this instance, we cannot say that. Why? Because of the straight line does not continue to infinity on either side, meaning that this side doesn't continue to infinity. If it did, this was going to be the domain. But this time around, this is the starting point. Yes? This is the starting point. Yeah, no, this question is often ukuthi cool. They want us to give the domain of, okay. No, that's fine. That's fine. That's fine. Let's do this. Now the domain is going to be x element of x to infinity. In fact, we include the x. But this x, which x am I referring to? This x value. The x value for the c, because of the domain starts here from the x value of the c point all the way up to infinity. So this means that we need to calculate the value of c first, the x coordinate of c first. How do we do that? We go to the g function. This is g equal to minus 1 over 2 x plus 3. So the c point has an x which is unknown, and the y value, that is 4. So where there's y, I substitute 4 equal to minus 1 over 2x plus 3. Let's transpose the 3, and then we are left with a 1 that is equal to minus 1 over 2x, and then divide both sides by negative half. We have a negative 2 that is equal to x. So this means that the domain starts from that negative 2. It starts from negative 2 to a positive infinity. This is our answer then. Now this is our answer for 3.1.3. Okay, next question, 3.1.4. 3.1.4. We have to give the equation of h of x if the g of x is translated 6 units down. So this is g of x. This is g of x. G of x is equal to negative 1 over 2x plus 3. There's a new function that is h of x, which is equal to taking g and translating it 6 units down, minus 6. If your function is translated down, you subtract. If it's translated upward, you do what? You add. You're gonna add. So this is equal to minus 1 over 2x plus 3 minus what? Minus 6 is equal to negative 1 over 2x plus 3 minus 6, negative 3. So this is the function for h of x. Now this concludes 3.1, the first part of the question 3. Let's hide everything under 3.1. So here there's gonna be a little bit of heavy lifting because we need to sketch something. 3.2.1, sketch the graph of k of x. Which function is that? It's the given one. Clearly indicate the x and y intercept. Show the asymptotes as well. Use addendum A attached to sketch the graph. So we are provided with a grid for this one, with a grid. But before we start plotting, let's go ahead and calculate the x and y intercepts first. Alright, so we have this k of x equal to minus 1 over x minus 1 minus 1 over 2. This is 3.2.1. Okay, so we're gonna have to find the y-intercept first. So y-intercept let x to be 0 for this one. So we have y that is equal to minus 1 over 0 minus 1 minus a half. Y is equal to 1 minus half. Y is equal to 1 minus a half. That gives us a positive half. So the coordinate, the x coordinate, is gonna be 0 and a half, a positive half. And then we work out the x-intercept as well. The x-intercept, that is y equal to 0. 0 is going to be equal to minus 1 over x minus 1 minus a half. Transpose the negative half. It gets to the other side by a positive. Minus 1 over x minus 1. We cross multiply. X minus 1 equal to 2 times minus 1. That's a negative 2. Transpose the 1. It's equal to negative 2 plus 1. X is equal to minus 1. We have a coordinate, a point that is minus 1 and 0. We have the x-intercept as well as the y-intercept. Okay, now let's go ahead and get the asymptotes. So we have two asymptotes, the x asymptote, which is the vertical asymptote, also the y asymptote. So let's start with this one, the x asymptote. So you take the x minus 1, you equate to 0, then you make x the subject of the formula. So this is the first asymptote. Asymptotes. All right, x equal to 1. Now for the y asymptote, we're going to have a y that is equal to minus 1 over 2. Minus 1 over 2. That's the next asymptote. So I think we're ready to plot now. We are, in fact. We are. So here's the grid. This is the provided grid on the question paper. So let me shift it on the side and have maybe something like, okay, let me plot here, and then let's have a straight line that goes like this and another straight line that goes like this, the x-axis. All right, so we have the y, we have the x, okay, and then we have points. Let's mark down the scale here. All right, let's mark down the scale. Mark. Then you have 1, 2, 3, 4, 5, 6. I know the numbering is gonna make this thing a bit ugly, but just make sure you number your scale as well. You have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, and minus 7. I think we can use this color to plot. Okay, now let's plot our function. Let's start with our asymptotes, which is x equal to 1, right? Here goes the first asymptote. I don't think I need a dotted line, man. Let's go ahead and let's try this. Same as the number. Yeah, okay, perfect. Let's use purple. Purple. It's the first asymptote. Next asymptote, it's y equal to negative half. So negative half is between 0 and negative 1. So we're going to draw a line across like this. So this is the y asymptote. Now let's plot our x-intercept. So x-intercept is minus 1 and 0. Minus 1 and 0. And then we have the y-intercept as well. that is 0.5. It's somewhere here. 0.5. Then it's 0.5, and then this side it's gonna be -1 and 0. All right, -1 and 0, and then we can plot here now. But first, note the following. If a is bigger than 0, expect your function to go like this, to be in the second and the fourth quad, right? But if your a is less than, what am I saying? It's actually the other way around. Less than, then you're gonna have your graph in the second and third. But then if a is less than 0, no, not less than, but greater than this time. Yeah, ne? Okay, it's greater than 0. Greater than 0, we're gonna have a situation where the graph lies in the first as well as the third quadrant. Okay, so now looking back to our graph, we can see that we had a -1, so it means that the a value, where's the a coming from? I'm sure the generic equation for a hyperbola is a over x minus p plus q. The a, it's this value right here. It's that value right here. If a is negative, it means that my graph is gonna be in the second and the fourth quadrant. So for the fourth quadrant, you can just draw a curve like this. All right, draw a curve like this. Just make it a habit that you also label your axes. That's 1, y equal to -1/2. So this is our sketch. Okay, this is our sketch. Now let's do the last section for this question 3. Let's hide this as well. Let's go ahead and do this one. Guys, back your formula sheet when it comes to solving or answering questions on functions. In case you forget the equations of the different functions, just go to your formula sheet. The formulas are there. Now let's wrap this up with this 3.3. So given below are the graphs of P, which is the parabola. The A is unknown, the B is unknown, the C is unknown, and then we have Q, which is the hyperbolic function. The hyperbolic function, however, is sketched where x is greater than 0, which means the first quadrant. The graph of f intersects the x-axis at points A, right here, and B, right here. C is a point on the graph of P. Wait a minute. Okay. The graph of f intersects the x-axis. Yeah, no, there's a typo. The graph of P, not f. There's a typo here. The graph of P, it's okay. The graph of P intersects the x-axis at these points. No, it's not f. It's P actually. All right. It intersects at A and B. And then functions are not necessarily drawn to scale. Then for the first question, they want us to show that the values for A, B, and C are equal to those values for the equation of Px. So 3, 3, 1. We have P of x that is equal to ax squared plus bx plus c. Here we go. So we have to find the value for A, the value for B, as well as the value for C. We need to calculate these different values, okay? So what do we do then? You need to understand or find out what you are given on the sketch. We are given two x-intercepts, the A and the B. We are also given a random point on the sketch of P, right? So how do you deal with such a situation now? If you want the equation for a parabola and you are given the x-intercepts, use this formula. That is y equal to a x minus x1 x minus x2. This is in your formula sheet, in your formula sheet, your formula sheet. Okay, y is equal to that. Y is equal to a. Then we start substituting the x coordinates. X minus, what is x1? X1, we're going to be substituting that negative 3.5, negative 3.5, close. We have an x that is minus x2. X2, it's going to be that 1. Then we simplify that, where we end up with an x that is x plus 3.5, x minus 1, okay, x minus 1. And then we have to calculate the value for a, right? The value for a. So to calculate a, substitute the extra given point, the extra given point. This point C, it's another point that lies on the graph. So A was substituted now. B was substituted as well, right here. Né? To work out what A is, substitute the extra point. Not the x-intercept, but the point, the other point that is given. Where there's y, we substitute 9 equal to A. In bracket, we're going to have x that is minus 2 plus 3.5. Close bracket, open bracket. We then have minus 2 minus 1, close bracket. Then we simplify. We have 9 that is equal to a. In bracket, this you can just punch on your calculator, so I'm gonna do that. Minus 2 minus 3.5, close bracket, minus 2 minus 1, close bracket. We now have 16.5. Divide both sides by 16.5. 16.5 cancel. We now have 9 over 16.5 equal to, that is 6 over 11 equal to A. Okay, you know, we are not used to getting such strange answers like my functions. What is wrong? Okay, all right, let me check. Okay, no, I see my mistake. Instead of punching in a positive, I punched in a negative instead. So let me fix that. It's a plus equal to, okay, we have a 9 over negative 9 over 3, negative 9 over 2. So let me erase this. So we have 9 that is equal to a, in bracket negative 9 over 2. Then we divide by negative 9 over 2. Negative 9 over 2 cancel, a now becomes 9 divided by negative 9 over 2. Answer, it's negative 2. Yeah, this makes sense. You get a funny answer, nyana. So just try to go back to your calculations and verify. We normally get like fractions, like proper fractions, or whole numbers, negative numbers, but just numbers that make sense, not that 6 over 11 thing we got. All right, so we have our first value of a, and another thing, we are told that a should be equal to -2. Let's work out the value for b. Let's work out the value for b and c. So it means that we're gonna go back to this step, sizothi-ke now y is equal to -2, so I'm substituting the a value this time around. X plus, what is 3/5? I mean 3,5. That is, I think, yeah, 7,5. I mean 7/2. Close bracket, open another one, x minus 1. All right, the 7/2 is just a fraction that is equal to the 3.5. Now we punch out calculator, this thing, it changes to a 3/5. I mean a 7/2. Now what do we do next? We multiply these two brackets, 7 minus 2, or what you can do, take this 2 or multiplying, you can do that, minus 2x and a minus 7 in bracket x minus 1. What I did, I took the 2, I substituted, I multiply the first bracket, y equal to, then we FOIL, this times that, it's a minus 2x squared, this times that, it's a plus 2x, this times that, it's a minus 7x, this times that, it's a plus 7. Y is equal to minus 2x squared minus 5x and a plus 7. So a -2, b -5, and then c is equal to the +7. So this gives us our answer. This gives us our answer. Now they want the domain, I mean the range for p, which is the parabola. So the range for the p, you look at your y values that are possible for this function. So the function yami, it starts from the turning point and then it goes all the way down to -infinity. Right, to -infinity. All right, so for this, I think I'll have to scratch this out, create another slide, 3.3.2. all right, okay, what is it that I need to answer this question? I need the turning point. For this function, right? So I have y that is equal to minus 2x squared, a minus 5x, and a plus 7. X is gonna be equal to minus b over 2a, equal to minus, what is b? -5 divided by 2, -2, multiply, we end up with a -5/4. -5/4. Then we take this x value and sub it into the original equation, and then we have minus 2 minus 5/4 squared minus 5 and the minus 5/4 and the plus 7. Then let's calculate y. -2 -5/4 close squared minus 5 and -5/2, not squared, okay, plus 7. I'm getting 131/8 is my answer, and then in decimal form it's gonna be 16 -2, yes, okay, not 4, it's 2 upper. Interesting. Oh, okay, no, let me fix my calculator issue here. 4, yes, I'm getting an 81/8. Yeah, cause Niyanghlafunya lapha kuma comment section. Yeah, hey, uphanje answer yakho i-wrong lapha se. I-wrong, i-wrong, i-wrong. So I'm trying to be more cautious, extra careful this time. Okay, so this is the y value for the turning point. So the range starts from the turning point going down. So y less than or equal to 81 over 8 for the parabola. So it starts here and then here pans it to negative infinity. 3.3.3 for which values of x is q decreasing? For which values of x is q decreasing? So we can see that q, which in this case it's the hyperbola part. Where is it decreasing? The x values showing that the function is decreasing in this part. It starts from 0 to positive infinity. So x element of 0 to positive infinity. This is where my function is decreasing. All right, so I'm going to end this discussion here. This is the last part of the question 3. I hope we enjoyed it. I hope you got some value out of it. If you did, leave a like, share, subscribe. So for now, I'm signing out. On the next one. Bye bye.